Hello everyone, welcome to an algebra tutorial learning about graphing linear inequalities. This is our second example, so I want to do a couple things different, but we're still going to get into how do we represent all the ordered pairs, all the x and y values that I can put in that make this inequality true. So here we've got 3 times some number x plus 2 times some number y together have to be less than or equal to 14. All right, we're going to graph all the possible ordered pairs on the coordinate plane to show that the ones that work. Okay, so here we go. Let's start graphing. The first thing I want to do is actually the first thing I want to do is I want to get it into slope-intercept form. It's helpful to know what is going on, what to do with the y values. It's helpful to graph. So let's get it into that slope-intercept form. So I'm going to let's write it out here. So we've got 3x. This one I've got to do some rearranging. 3x plus 2y is less than or equal to 14. I got some rearranging to solve for y. So I'm going to subtract 3x from both sides. Now I've got 2 times y is less than or equal to negative 3x plus 14. And I'm going to divide both sides by 2. So now it gives me y is less than or equal to negative 3 halves x plus 7. Okay, we're going to hang on to that. Actually, for kicks, want to graph this a different way. Going back over here, I've already got it set up in standard form. Sometimes the easy way to do it in standard form is just to find your x and y intercepts. So if x is 0, and I put 0 in for x, that means I end up with just 2y is less than or equal to 14. And if I solve that out, think about it as an equation to find the boundary line, divide both sides by 2, then y is equal to 7. Now I changed that to an equal sign, but I want to find the boundary line. What I just ended up finding was the y-intercept, 1, 2, 3, 4, 5, 6, 7, has to be right here. So I'm going to go and mark that dot. There's my y-intercept. And what we're doing is I'm going to go back and forth between dealing with the inequality, but then also thinking about the boundary line, because I need to know, well, what am I less than or equal to? So I got to find that boundary line. So we found the y-intercept of the boundary line. Now let's go find the x-intercept of the boundary line. So when y is 0, if I put 0 in for y, I end up with 3 times x is equal to 14. We're going to find the x-intercept, dividing both sides by 3. X should equal 14 thirds, which 3 goes into 14 4 times, with the remainder 2. So 4 and 2/3. So the x-intercept is over 1, 2, 3, 4, and right about there, 4 and 2/3. So there's my x and y intercepts. It's just a different way to graph. Again, I can see my y-intercept of 7 there, and I can use my slope of negative 3 halves and get to the same thing as well. But, you know, it's a second example, so I wanted to do a different method. So we got it in slope-intercept form. We're starting to draw that boundary line. That was step 2. So we need to know, what am I greater than or less than from? But now I need to think, well, is it a solid line that I'm going to use for the boundary, or am I going to make a dashed line? Now remember, that was all dependent on what type of inequality I'm having. So it's less than, so it means I'm going to need to deal with, am I less than or greater than, all that good stuff. But it's also equal to. Notice that little equals line right there. Since it's equal to, that means I'm going to want a solid line. It's equal to the line and less than the line. So I need to make a solid line and then figure out where to shade it up or down. So I've got my x or y intercepts. So I'm going to go ahead and make a nice solid line. Solid lines on this program are much easier to make than dashed lines. There's there's a rough solid line. There you go. Solid line because we have a less than or equal to inequality. So now I've got my boundary line. I've got it in slope-intercept form. Step 3, I need to shade a side. And what that means is now I'm shading the side that is the inequality that I want, all the possible solution sets. All the dots, if I was to draw all the ordered pairs and dot them all in, shading kind of represents all the possible dots I could make. So here we go back to which side do I shade? I go back to my slope-intercept form. Y is less than or equal to the line. So y values get smaller or less as I go down. So the solution set is everything downwards of the line. That's where decreasing y values. Y is less than. So there's all my less than values. So all the stuff in the red there, all these points are all possible solutions, ordered pairs that satisfy the inequality. So we shaded down because y was less than all that stuff, negative 3x plus 7. All right, let's do a test point just to make sure because that's always kind of fun. Let's test this point right here, right there. So the coordinates of that point are an x value of 10 and a y value of 9. If we put that in, so if I put 10 in for x and 9 in for y, it's not in the shaded set, so it should not work out. It should not be an ordered pair that satisfies the inequality. So let's test it out. Let's make sure though. So does 3 times putting 10 in for x plus 2 times y, we picked a y value of 9, is that less than or equal to 14? Well, 3 times 10 is 30. 2 times 9 is 18. 30 plus 18 is 48. Is 48 less than or equal to 14? No. So we tested it out. That's not a solution, which is what we would hope for, right? It's not in the solution set. So there we go. All the stuff in the red there on down below our boundary line is a solution, and everything on the boundary line is a solution. So if I happen to pick a point on the line, that is a solution that should satisfy the inequality as well, because the inequality includes all the points that are equal to 14 as well. All right, there's another good example of graphing all the solutions to a linear inequality, recognizing there's an infinite number of solutions, and just kind of thinking through, do I shade up, do I shade down? Is it a solid line or is it a dashed line? How do I know which side to shade? How do I test if I did it right? We went through all those things in this example.